Today we see about static electric field. The electrostatics is nothing but study of electric charges at rest. We know two types of charges are there, positive charge and negative charges. The charges at rest, it can be produced some field, that field is called as static electric field. So here the electric field does not vary with respect to time. So here it is invariant, so that it's called static electric field. Suppose the electric field is varying with respect to time, it's called dynamic electric field. Today we see about static electric field. The electric field at rest, it can be produces charge, that is called static electric field. The examples for static electric fields are a field used in cathode ray tube for focusing and deflecting a film, keyboards, touch pads, liquid crystal displays, etc. all are worked based on the principle of electrostatics. And also variety of machines such as x-rays, medical instruments, scanning machines, all are worked based on the principles of electrostatics. Electrostatic is nothing but the charges at rest, it can be produces the field, that field is called static electric field. And where we can use this static electric fields means many industrial applications and medical applications and agriculture activities. So the many of the places we have to use static electric fields. And the many components such as resistors, capacitor, etc. the device such as bipolar transistor, field effect transistor, all are based on the electrostatics. So two types of charges are there. One is static positive charge and another one is negative charge. So for any atoms that loses some ions, that becomes positive ion. Of any atoms that pick up one or more ions extra to that account, that is called negatively charged. So two types of charges are there, positive charge and negative charge. Positive charge means it loses the ions, and negative charges means it pick up the charge ions. So two or more charges are there means, so how to add all the how to add the electric fields means by using the superposition principle. So we have to add two or more charges. So we have to consider one charge is a test charge or unit charge. So we have to two or more number of charges are there means which charge having a dimension is very small, that we can consider as unit charge, and remaining charges we have to take as charge 1, charge 2, charge 3, etc. So we have to we need the total electric field around that unit charge means total electric field is equal to E1 plus E2 plus E3. So E1 is the electric field due to the charge 1, and similarly E2 is a electric field due to charge 2, and then E3 means the electric field due to charge 3. So we have to adding all the charges, we have to get total electric fields in any space. So here based on the two charges and the distance between the two charges, so we have to derive one law. That law we can call as Coulomb's law. So what's the Coulomb's law means, we are having two charges, so we have to take the magnitude of two charges and how what's the distance between these two charges. So based on that we have to derive Coulomb's law. So the force between these two charges is directly proportional to the magnitude of two charges and inversely proportional to the square of the distance between them. So here F is equal to, F is directly proportional to magnitude of two charges, that is Q1, Q2, and inversely proportional to square of the distance between them, that is R squared. R is nothing but distance between the two charges Q1 and Q2. So in order to remove the proportionality constant, we have to introduce one constant K. K is nothing but 4 pi 1 divided by 4 pi epsilon. Epsilon is a permittivity of the medium. Suppose the media is air media, epsilon equal to epsilon naught, and its value is equal to 8.854 into 10 to the power minus 12. So this is the force between these two charges. So we are having two charges. So in between the two charges we have to calculate the force means by using Coulomb's law we have to calculate the force between the two charges. So next we see about electric field intensity. Electric field intensity is also referred as electric field. So electric field intensity at a point in a space is defined as force per unit positive charge. experienced by a small test charge placed at that point without disturbing original field. So we know what is meant by force between the two charges. Force per unit test charge is called electric field or electric field intensity, that is denoted a letter capital E. So unit charge or test charge is nothing but any charge whose dimension is very small, that is called unit test charge. So E is equal to F by Q. So E is an electric field intensity, F is a force experienced by the test charge, and Q is the magnitude of the test charge. So F by Q, that is called electric field or electric field intensity. So next, electric flux. So here in a surface we are having a number of electric field lines. So based on the number of electric field lines we have to measure electric flux. So what is meant by electric flux means electric flux measures how much electric field is passes through a given surface. So we are taking in one surface, in that surface how much electric field lines are there. So based on that thing we have to define electric flux. So the electric flux is nothing but sense of number of electric field lines crossing the surface. So electric flux is denoted a letter phi. Phi is equal to E dot A. So A is nothing but area given surface. So E dot A, in order to remove the dot product, so we have to take EA cos theta. So phi E for non-uniform field means surface integral of E dot dA. dA is nothing but area of this particular surface. So theta is nothing but angle between E and dA. So this is a electric flux. So electric flux is nothing but number of electric field lines crossing a surface. So next we have to define the term is electric potential. So electric potential is nothing but electric at a point in is the amount of electric potential energy per unit charge at that point in a electric field. So what's a potential and per unit charge is called electric potential. So it tells that how much work is needed to bring the unit positive charge from a reference point to that point. So here it's nothing but electric potential is nothing but work done per charge. Work done per charge. So here V is an electric potential, U is an work done, and Q is the test charge. So here potential is a scalar quantity. So V is equal to Q by 4 pi epsilon R. So this is a electric potential. So up to this we have to see what is meant by electric field, what is meant by static electric field, what are the where we have to use this electrostatic principles, and what are the applications of electrostatic principles, and what is meant by Coulomb's law, what is meant by electric field or electric field intensity. More number of electric field is there, how to add these electric fields by applying a superposition principle, and then what is meant by electric flux and potential, what is meant by electric potential. So these are the some ideas about static electric field. So next class we see about what is meant by static magnetic field. Thank you.